The lesson topic for this video is graphing parabolas, and this is an introduction to the characteristics of a parabola. So first of all, let's make sure we know what this word parabola means. We've talked about it before, but a parabola is the shape of the graph that occurs when you have a quadratic function. All right, so if you look at these three examples off to the right, the U-shaped graph is a parabola. So this is a parabola, this is a parabola, and this down here is also a parabola. All right, so a U-shaped graph. So a few words or terms that go along with parabola. All right, we're going to start with the term vertex. Well, the vertex of a parabola is the highest or lowest point of the parabola. It is also known as the maximum or minimum, which we have discussed in class already. So this parabola right here has, in this case, the lowest point down here, which is then a minimum, and that is right there, the vertex. So in red here, I'm going to just label this with a dot as my vertex, right? All right, so the other two graphs, this is the vertex of this one, and it is also a minimum, and the vertex on this one down here is up here, and this is a maximum point. And it's still known as the vertex, but it's a maximum because it's the uppermost point of the parabola. All right, so that's vertex. Now the equation for the line of symmetry is next. Now we've all talked about symmetry before in probably many other grades. Symmetry, if you think about it, like a heart has symmetry. Remember that word from back in the day? Symmetry means that if we cut it down a certain line, both sides of that line will be a reflection of each other. Now my heart wasn't perfect there, but I think you get the idea. So symmetry. Well, if you think about it, a parabola has symmetry because if I cut it down the middle and through the vertex, both sides of the parabola would be a reflection of each other. So the equation for the line of symmetry is a vertical line that divides the parabola into two congruent halves. All right, so when we draw this on our coordinate planes, we're typically going to draw it with a dashed line to show that this is not actually the function we're graphing, but a helpful line, in this case a line of symmetry. So a dotted line through the center, and we know that through the center of the parabola means it will always go through the vertex, because that is the middle for the highest or lowest point. Okay, so a line of symmetry looks like this. And since we know it's a vertical line, I want to remind you, this is an important thing to remember. A vertical line always, for the equation of a vertical line, we always have an x equals a value. X equals a value. If you look at this line right here, we would call that x equals negative 3. That is the line x equals negative 3 in this case, in the first case. So that tells us that it's a vertical line, and that's the location of it. So that's the equation for the line or axis of symmetry. So our other two parabolas, we'd have our line of symmetry right through the y-axis, which isn't always easy to draw. So there's our line of symmetry there. And this one off to the right through the center of the parabola. Again, it's always, always, always going to go through the vertex. All right. Next, X-intercepts. Well, we've talked about X-intercepts before. X-intercepts are where, sorry about this, hold on. The location or locations, if one exists, we're going to talk about that in a second, where the parabola crosses the x-axis. All right, so in this first example, we have two locations where the parabola crosses the x-axis. Remember, this is the x-axis. So here's one location right here, and then here's one location right here. So those are called our x-intercepts. And if you remember, our x-intercepts are always a number, comma, 0. And again, typically we have two of them, not always. So location or locations if one exists. Now this part is shown right here. This parabola does not cross the x-axis, right? There's the x-axis. The parabola doesn't cross it, so this is an example where there are no x-intercepts. Okay? This example down here is a good one to explain to you that it does still have two x-intercepts. We just can't currently see one of them. So one of our x-intercepts is right here, and the other one is over here somewhere, and we would have to extend our window in order to see that location. So this is not an example where there's only one. This still has two. If you think about where it would be when we only have one location where the graph or the parabola crosses the x-axis, it would be if the parabola was sitting right on, or the vertex was sitting right on the x-axis. Then there would only be one x-intercept. All right, and then we have y-intercept, and we know that a y-intercept is the location where the parabola crosses the y-axis. Notice it doesn't have more than one option. It doesn't say location or locations if one exists. With a parabola, there will always be a location where the graph crosses the y-axis. All right. Y-intercepts, remember, is going to be 0 for our x value, and our y value will be filled in for our y-intercept. If you look at the first example, our y-intercept is up here at 10. It crosses right through that location right there, so 10, 0. Our next one crosses, this is again an interesting difference here for this parabola, is that our y-intercept is the same as our vertex in this case, because the vertex is on the y-axis. So again, we're looking for the y-intercept on the y-axis. And for this last one down here, again, it does exist. It's just going to exist way, way, way down, much further below -10, probably even lower than -20, perhaps, kind of judging by the curve of the parabola. So we'd have to change our window if we were trying to read this from a graph. Remembering that our y-intercept always has a 0 for x and a value for y, and there will always just be one of them. All right, let's take a look at how we're going to use this. Okay, so what we're going to do here is we have our function. It's quadratic, we know, because x squared is our highest exponent on the variable x, so we have a quadratic function. We are going to find some y values when we have some x value inputs. Then we're going to find the vertex, the line of symmetry, the x-intercepts, and the y-intercepts, and we are going to graph it. All right, so how we're going to do this first part is notice we know the value of x. And what we do in this class, when we know the value of x, we find the value of y, or the output, by using our graphing calculator. So go ahead, put this function into your graphing calculator, and compute f of -6, f of -2, f of 0, f of 2, and f of 4. So we're going to use trace. Go ahead and fill in that chart. So starting this chart, hopefully you already did. When I went in, I put my equation into the graphing calculator, and I used trace -6, and I found my y value to be 0. So we want to go ahead and fill all those in. So trace -2 is -8. Trace 0, we get -6. Trace 2, we get 0. And trace 4, we get 10. So I went through and I did that for all my x values, and I found my outputs for y. All right, so now let's go ahead and plot these points on our coordinate plane. So we have -6, 0, which is right here. Let me get, okay, right there. And then we have -2, -8, so -2, -8. And then we have 0, -6, and 2, 0, and 4, 10. All right, so kind of large dots there. All right, so what we have is just a series of points, and it's probably not quite enough to get a real great feel for this parabola, but we can see that it's taking shape like so, which we do see on our graphing calculator as well. Now, it is going to look a little different because the window, especially on the Casios, has a big spread for our x axis, and here ours is more of a square, so it will look a little different. But we are going to then use this information to graph our parabola. Okay, like so. It's a little bit Well, it's not perfect is what I'm trying to say. But anyways, here we go. Let's move along. The vertex. All right, well, the vertex we decided is the very lowest or highest point of a parabola depending on how it opens. And this opens up, it has a minimum. And so this point right here is our vertex. So we're going to go ahead and write that point is -2, -8, right? -2, -8. There's our vertex. Our equation for our line of symmetry then, and let me go ahead and put a red dot there for my vertex. Our equation for our line of symmetry, again, the line of symmetry goes through this right here, through the vertex. So we know it's a vertical line through the vertex. So it is x equals -2. One thing you want to notice right away is that this x value will always be the same as this x value of our vertex. It will always be the same. That's actually a huge thing you're going to need to know this unit. The x value, -2, for the vertex will always be the exact same x value for your line of symmetry because it goes through that same x value. All right, our x-intercepts. Where does the graph cross the x-axis? Well, that's right here and right here. Okay. Notice we can also find those because we said in the previous slide that x-intercept is a number, comma 0 and a number, comma 0. And we can see that in the chart right here. Which values do we have where the y is 0? Well, -6 and 2. So -6, which we see right here, -6, and 2, which we see right over here. So -6, 0, and 2, 0. You can also list your x-intercepts as simply -6 and 2. Our y-intercept, where does our graph cross the y-axis? Well, our graph crosses the y-axis right here at -6. And again, we can see that because if we put a 0 in for x, we notice right here a 0 in for x gives us a y value of -6. So there's our y-intercept. So these are the key pieces of a parabola that we are going to need to know very, very well. The vertex, line of symmetry, the x-intercepts, and the y-intercept. Oh, and one last thing. A student asked me to put a bad math joke in this video, so I will. Question: what do you call a number that can't keep still? The answer is a Roman numeral. Ah, love it.